Okay, so let's take a look at this problem and figure out which of these answers are correct. In fact, this was sort of a trick question, and all of the answers are correct. The first thing I want to address is the end groups. So answer A and B have the end groups specifically drawn out. And we normally don't do that with polymers because if N, the number of repeat units, is large enough, we might not know what the end group is, and we probably don't really care either. It's statistically such a small part of the molecule that it just doesn't really matter. Now, if you do draw out the end group, it is a best practice to do N-1 in front of the small molecule byproduct because then you'll have a balanced equation. So I made this little frame so we can look at just what is the repeat unit. So if we look at just inside those brackets, there's our repeat unit. Here we have oxygen, R carbonyl. Here we have R carbonyl oxygen, oxygen R carbonyl. So that is the same as the first one. This one has the end groups and this one does not, right? We see those end groups, so A and C. And then we have R carbonyl oxygen. So again, B and D are the same. You just are seeing the end groups and not the end groups. So how do we know that these two, right, that A and C are actually the same as B and D? The easiest way to figure that out is to really think about what it means, what a repeat unit means. It means that if I write oxygen R carbonyl N times, I'm going to get the same thing as if I write R carbonyl oxygen, R carbonyl oxygen. If I write that out N times, do I get the same molecule? So I have written out a whole bunch of repeat units here. So if I use my little frame, here we go. I've got oxygen R carbonyl. If I move it over, I've got oxygen R carbonyl. Oxygen R carbonyl. I can do that over and over and over. But now what's the second one? Here we've got R carbonyl oxygen. So if I just start there, now I've got R carbonyl oxygen. My next unit, R carbonyl oxygen. My next one, R carbonyl oxygen. So that is totally fine. Actually, I could have added another answer to this and started with carbonyl oxygen R, right? But that's just A flipped over, right? So you can write your repeat unit any way you want to, as long as you have every atom that's necessary for the repeat unit, right? And properly connected properly and in the right order, right? So it doesn't matter if we start with the oxygen or with the R group or with the carbonyl, because we can just go carbonyl oxygen R, carbonyl oxygen R. We get the same thing. They're all equivalent. I will tell you, I tend to write it where I can see about the monomer, right? So there's the monomer. My frame is a little too big to cut off that oxygen. That's why I'm using my finger. But so if I have that monomer structure, I just tend to leave it in the same way I see it in the monomer. But there's no requirement. So if you write it this way, it can be easier to figure out, oh, what was the monomer? But if you write it this way, it's easier to see that ester group. The carbonyl oxygen is the ester group, and so you're not splitting the ester. So some people like this way better than this way. It's a matter of preference. So again, all of these answers are equally correct. And question 2 on this sheet, is this an example of an AB or an AA type polymerization? Hopefully you all know that it's an AB type polymerization, right? We've got an alcohol and an acid, so 2 different functional groups in one monomer, which makes it an AB type. We don't have the equivalent AABB type would be a diol reacting with a diacid, and that's not what we have in this case. In the next video, we are going to be looking at this polymerization in more detail and even look at the mechanism of how that polymerization occurs.